Welcome back to Summarize Science. Today, we are looking at a potential breakthrough in detecting one of the most aggressive and lethal diseases, pancreatic cancer. Currently, pancreatic cancer is projected to become the second leading cause of cancer-related death in the United States by 2030. Part of why it is so deadly is that it is often clinically occult, meaning it hides without symptoms until it reaches a very late stage. Because it is relatively rare, screening the entire population with expensive scans like MRIs is simply not practical or affordable. This is where the researchers stepped in to create a digital solution. They developed a new tool that looks for latent indicators of the disease buried in routine medical records. The AI model analyzes an individual's history of diagnosis codes and simple blood test results collected over many years. To build this, they used a multi-institutional cohort of over 183,000 patients, including over 6,000 who were diagnosed with pancreatic cancer. The model looks at clinical history data spanning up to 20 years for some patients. The technology behind this is a transformer-based neural network, which is the same type of technology used to power modern AI chatbots. Instead of reading words in a sentence, this AI reads health trajectories to see how a person's medical profile evolves over time. The results were impressive, showing that the model could predict cancer risk with high accuracy 1, 2, or even 3 years before a diagnosis. In many cases, the signals of the disease began to emerge in the data as early as 5 years ahead of time. The AI identified several important factors, including changes in metabolic markers, liver function, and even counts of basic blood cells. Even things like vaccination history and benign conditions like pancreatitis played a role in the prediction. To make this useful for doctors, the researchers proposed a 3-stage screening pipeline. First, the digital tool would flag high-risk individuals during their routine checkups. Those flagged would then receive a non-invasive CT scan analyzed by a second AI model specialized in finding hidden tumors. Finally, only the most likely cases would proceed to an invasive biopsy for confirmation. This combined approach could improve screening efficiency by more than 8 times compared to current methods. It also catches the 60% of patients who do not have standard risk factors like a family history of the disease. In summary, the researchers have laid the foundation for a population-level digital enrichment tool. By using routine blood tests that people already get, this system makes early detection much more scalable. The goal for the future is to move from reacting to late-stage cancer to intercepting it while it is still treatable. This digital bridge could finally give medical teams the lead time they need to save thousands of lives. Thanks for watching Summarize Science.